Alright, so check your answers. Okay? Just simplifying these radicals. You always want to make sure that your denominator is rationalized so there's no radicals down there. So check your answers. If you want to go over any when we come back, circle them or star them so we know. Okay, check your answers for this page. Alright, so we want to rationalize this denominator. If this is a cube root, you're going to multiply 3 times. If it's a square root, you only do it twice. Okay, so we'll go through all that. Down on these ones, where you have something plus a radical or something minus a radical, that you're going to use the complex, or the conjugate, which is just 1 plus root 3. Now you change the sign of your radical term. And when you go through that, you end up with this. So this is multiplication on both sides, or on top and bottom. So when you do all that, you end up with this. This one, this would be 2 plus root 10. 2 plus root 10. So when you do that, it gets all weird. All right, so this is a review. It's going to be on, something like this will be on the final, or in the course exam. So we need to solve for z. I know these are your favorites, but we take a look here. If you look, this is positive 2y, this is negative 2y, so let's eliminate these. X plus 2y minus equals 5, and then negative 3x minus 2y. Okay, let's eliminate these. So you get negative 2x minus 4z equals 16. Okay? I know normally we solve for x and then do this other stuff, but we want to get z specifically. We want to get z as fast as possible. So to do that, we just cancel out the y's here. So we need to find another equation we can use to cancel out the y's again. So we used these two. Now, if you notice, we can use these two. This is a negative 2, positive 4. All we have to do is multiply this top one by 2, and you'll get negative 6x minus 4y minus 6z equals 22. So when you do that, you get negative 2x minus z equals 4. Okay, there's our other equation. Okay, so now we're going to solve one of these equations to substitute into the other equation. I would suggest solving for negative 2x. Okay, this is a kind of a very sophisticated way of doing it. We don't have to solve for x and then substitute it in. Since we have a negative 2x here and a negative 2x there, we can solve for negative 2x. So we'll have negative 2x is equal to 4z plus 16. Okay? Then we substitute, so this is negative 2x, negative 2x. We substitute this in right there. And you get 4z plus 16 minus z equals 4. The reason this is not multiplied by negative 2 is because this whole quantity is negative 2x. Okay, it's not just x, it's negative 2x. So you substitute this in for the whole thing, not just for x. So we go through and solve. 4z minus z is 3z. Move the 16 over. 4 minus 16 gives you negative 12. And z is negative 4, which I think is C. Okay, that's kind of a complex, sophisticated way of doing this. You don't have to solve for x and then substitute it in and multiply by negative 2 again. You can just solve for negative 2x and plug this whole thing in for that chunk, that term. Okay, so if I were you, I'd write this down. This is an example of how to do this kind of quicker. Okay, the way I do it in class is very stepped out. This one's a little quicker, just because if this is on a test, you don't want to be wasting time. So just to point out, we eliminated all the y's at x and z. You could eliminate the x's if you wanted, just have y and z, that would work too. It's just the y's work out real nice. Alright, so day 4 we've been doing just normal rationals, or radicals. Now we're going to be doing complex numbers. Complex numbers are pretty complex, as you might guess. Okay? So a complex number is a number that has a real part, so 1, 2, 3, real numbers, and an imaginary part. Now this imaginary part, we say is lowercase I. Now, complex numbers, you'll see a lot of that in upper level physics. It helps with, it helps explain dampening and all this stuff. So complex numbers are in the real world. It's just you don't see them very often. So complex number has a real part and an imaginary part. The imaginary part is I, and we say that I is equal to the square root of -1. This lets us deal with negative square roots or cube roots or anything like that. fourth root, sorry. Okay? I is square root of negative 1. So if you square I, okay, I squared is negative 1 squared, square root of negative 1 squared. When you do that, you just get what's inside. So I squared is negative 1. And we'll go over what I cubed, I to the fourth, I, all that stuff later. We have complex numbers. The imaginary part is I, which is the square root of negative 1. And there might be a real part to it. So over here, a plus bi, a is a real number and b is a real number. It's just I is the imaginary number. Okay. So basically imaginary number, you have real part a and bi, where b is not 0. If it's 0, this just cancels out and you get a, which is real. So as long as there's some type of I, it's going to be imaginary or complex. And so just to take a look, if we're factoring this, we can factor this into, okay, the factors of negative 144. You could say square root of 144 times the square root of negative 1. What's the square root of negative, or square root of 144? You should know this. 12. What's the square root of negative 1? I. So your answer is the square root of negative 144 is 12i. It's complex, it's imaginary. Okay, make sure if you have any questions, write them down, star them or something, so that when I come back we can go over them. Okay, so you guys try in your groups 2 through 5. A couple minutes. Let's take a look. Square root of negative 8, you could do this as square root of negative 1 times the square root of 8, which is square root of 4 times the square root of 2. We know this is just going to be 2. And don't forget your I. So this is going to be 2i times the square root of 2. So our square root of negative 1, it's all going to be in here. You kind of think of this as I times 2 times square root of negative 2. Okay, remember the square root of negative 1 is I. Okay, this one we can break down to square root of negative 1 times square root of 196. If you don't know what that is, okay, then you can just start dividing by 2. So 2 and 98. 2 and 49. Ooh, now we're getting somewhere. Square root of 49, that's 7. Since this is a square root, we're looking for pairs, so we can bring them out. So 2 times 7 times the square root of negative 1. We know this is I times 14, or if you want to rewrite it as 14I. If we take a look at negative 45, you could say this is negative square root of negative 1 times the square root of 45. So we can break this down into square root of 5 times the square root of 9. We know this is 3. We're left with the square root of 5 and the square root of negative 1. So we know this is I times the square root of 5 times 3, or to rearrange this, would be 3I square root of 5. Okay, if you're ever given a square root of a negative number, just bring out the negative 1. There's your I. And then factor it normally. Okay, number 5, we have a cube root of negative 64. Now, cube roots are a little different. We're looking for 3 things that will multiply to give you negative 64. Okay? So you might not be able to recognize this, but if you know that 64, okay, negative 4 times negative 4 times negative 4. This will give you positive 16 times negative 4. This will give you negative 64. So the cube root of negative 64 is just negative 4. Okay? Cube roots, you can have a negative in there, because you can have 3 negatives. When you multiply them together, they still give you a negative. Okay, so let's take a look at 6. To get rid of the squared, you are going to square root both sides. So you get x is the square root of negative 81. Oh no, what are we going to do? Okay, just factor this out. Square root of negative 1 times the square root of 81. We know the square root of 81, that's 9. We know that this is I. So x is going to equal 9i. Right, so in your groups, work on 7, 8, 9, and 10. A couple minutes in your groups.
Is it here?
Yeah.
Okay. Good.
All right, so let's take a look at these ones. We have to get x by itself, so you subtract 15, you get x squared equals negative 10. Oh, now, to get rid of the squared, you're going to square root. X is the square root of negative 10. So we go through. This is really the square root of negative 1 times the square root of 10. You can't simplify this, but you can, that's just I. So x is going to be I times the square root of 10. Take a look over here. We subtract 11 from both sides, and you get Negative 48 divided by 2. X squared is negative 24. To get rid of the squared, you square root. So x is the square root of negative 24. This is really square root of negative 1 times the square root of 24. Which you should be able to factor this as 4 and 6. We know this, that's I. We know this is 2. And you can't simplify the square root of 6. So your answer for 8 would be 2i times the square root of 6. And if you have any problems, just make sure you somehow mark it so we can go over when I come back. X cubed is negative 27. To get rid of the cube, we're going to cube root both sides. So x is the cube root of negative 27. And to figure out what thing multiplied 3 times will give you negative 27, you should know that it is, if you do negative 3 times negative 3 times negative 3, okay, this will give you positive 9 times negative 3. That gives you negative 27. So x is going to be negative 3. In cube roots, you can have negatives in there. Just whenever you have an even root, 2, 4, 6, 8, you can't have negative numbers in there. Okay, number 10, solve for x, so you get 5x squared is negative 16. X squared is negative 16 over 5. This is looking real crappy. So you square root. X is the square root of negative 16/5. Not looking good. We can say that this is the square root of negative 1 times the square root of 16/5. That makes it a little better, I guess. We know that this is just I. We can separate this as the square root of 16 over the square root of 5. We know that square root of 16 is 4. So we keep going. We have I times 4 over root 5. Okay, this is a correct answer, but it's not the most correct. So we have to rationalize our denominator. And to do that, you multiply the top and the bottom by the square root of 5. Okay, when you do that, you get 4i times the square root of 5 up top. Down here you have square root of 5 times square root of 5, which gives you 5. if you wanted to leave this as I times 4 root 5 over 5, you could do that, that's fine. Generally you'll have the I there, it doesn't matter. Or you could do this as 4 root 5 over 5 I if you wanted. That all works. It's all the same thing. Okay, one last thing with these complex numbers. We're going to add and subtract them like this. Okay, you add or subtract the real parts. Remember, the real parts are A. Okay, A plus BI. So your imaginary part's the B, real part's the A. So when you're adding and subtracting these, you add the real parts, then you add the imaginary parts. You cannot add them together. It's kind of like terms. Basically just like, if this was an X and an X. You have to combine like terms. So over here, our real part is a 7 and 2. So when you do 7 plus 2, you get 9. Come over here, your imaginary part is the 2 and the 8. So 2 plus 8 would give you 10i. Okay, another thing you can do is you can just say that this is R, I, just so you know which one you have to add together. So you add the two reals and then the two imaginaries. So in your groups, work on 12, 13, 14 real quick. Alright, so let's finish these off. To add these, I do the real parts. So 4 minus 2 would give you 6. Then we have a 3i, there's your imaginary part, 3, and this 8. So when you do this, this is going to be negative 2 and a positive 8i when you distribute this negative 1. So what is 3i plus 8i? I give you plus 11i. Over here we have our imaginary part. This is this -2 and this +2. Real part, 7 and 7. So what is 7 plus 7? That'll give you 14. Our imaginary part, 2i plus a -2i. That would technically be 0i, so your answer would just be 14. And lastly, we have our real parts here. 4 minus 6 gives you a -2. Our imaginary parts are a -5 and a -2 here. So, when you distribute this, this becomes -6 plus 2i. So, -5i plus 2i gives you -3i. Or you can think of it as -5i minus a -2i. Both ways of thinking about this work. Okay, so if your homework is just doing square root stuff, solving some equations, solving for x. Okay, remember cube roots. Where is it? Oh, nowhere. Okay, never mind. And these ones just remember add the real parts, and then add the imaginary parts separately. Okay. So we'll tackle some complex numbers again tomorrow.